Number 10, write a polynomial function with degree 4 real coefficients in standard form that has 3, -1, and 1 plus 5i zeros. Now remember, degree, that means the highest power will be x to the 4th. Or degree just means it's talking about the highest power. Since it's 4, it'll be x to the 4th. Standard form is in the form where we have like ax to the 4th plus bx to the 3rd plus all the way down. So that's the way form we're going to have. So if we have zeros here, this means that x equals 3. This one is that x equals -1, and here x equals 1 plus 5i. Now remember, with a conjugate, or rather with imaginaries, you'll always have the conjugate that comes with it, its conjugate pair, which will just be the opposite of the I term. So it would actually be 1 minus 5i. These are our zeros. Now to solve this, I'm going to write it out as f of x equals, and I want to plug these in parentheses. Now where would this come from? This would come from the parentheses. If you move the x back over to get it all on one side, it would be x minus 3. This would be x plus 1. And then these two, they'll switch as well. So I'm going to write this out. X minus 3 times x plus 1 over here. When we put this in parentheses, the signs would switch. So we'd have x minus 1. Let me write it over here. This would be x minus 1 minus 5i in parentheses. And then this one right here would be x, again, minus 1, this time plus 5i in parentheses, like that. Okay, now what we have to do is multiply these out. Now remember, I recommend doing the real times the real and the imaginary times the imaginary. So we're going to multiply these two together, and you could do a FOIL on this. With 3 terms, I oftentimes will do a box method for the 3 terms. So I'll do a box method here. I'll do FOIL there. So if I do FOIL on these, what I'll end up getting is x times x, which is x squared. X times 1 is 1x. -3 times x is -3x. And then -3 times 1 is -3. That's what I get there. Now for this, I'm going to do a box here. So my box method, I want 3. It's going to be 3 terms by 3 terms. Okay, and so for my box method, I'll have x minus 1 minus 5i, and it doesn't matter which goes on the left or which goes on the top. So I'm just writing it across, x minus 1 plus 5i. Now if I do this right, my i's should cancel out. So as I multiply here, I get x squared. This will be negative x. This will be 5ix. This here will be a negative x, a positive 1, a negative 5i. Here I get a negative 5ix. Run out of room here. This will be a positive 5i. And this will be a negative 25i squared. Okay, so what I know here is if this is positive 5x and this is negative 5x, these two cancel out. This is a negative 5i, this is positive 5i. These two cancel out. And I squared, remember, I squared equals -1. So this is actually here, that is negative 25, oops, times -1 is really what that is right there, which would equal 25. So I will replace that with 25. So when I combine our like terms here, or if I pulled them all down, without combining my like terms, I would have x squared minus x plus 1 plus 25. That's what I have there. Now let's simplify these. So I'd have x squared minus 2x minus 3, and I'm going to multiply that times x squared minus 2x plus 26. Now I'm going to do another box method for this. So here, I'm going to do one more box method. I know it's hard to see, but I'm just saying box method there on these two. So I'll do that one over here. Okay, so now I just copied my box. I saved the time to pause the video. So here's my new box. You can pause the video if you need to draw a box real quick. And I'm going to write these other terms out. X squared minus 2x plus 26. And I multiply through. And so we'll have x to the fourth minus 2x cubed. That'll be 26x squared. I'm really running out of room in here. Negative 2x cubed positive 4x squared. This would be negative 52x. This is negative 3x squared. That's positive 6x. And a negative 78. And so when you write out your terms here, x to the fourth, these are your x cubed, so negative 2x cubed, another negative 2x cubed. These are my squareds, plus 26x squared, plus 4x squared, minus 3x squared. These are my x's, minus 52x. I'm running out of room here. Oh my goodness. Plus 6x minus 78. And you really need to check your signs in here because you can easily mess up if you're not careful. Like this should be negative, this should be negative. You need to check these and make sure you get your signs correct. I could have easily gotten this off. So to finalize this, I will write this in standard form. So I have only one x to the fourth. I have two negatives. That becomes negative 4x cubed. I shouldn't say two negatives. What I mean is two separate terms that are both negative with x cubes. So these combine together. Okay, and then here's my x squared terms. I have this one here, here, and here. So 26, 30, 27. And then over here are my x terms. So these would become negative 46x, and then I have the minus 78 all alone at the end. This here is my answer. You could graph this, and what you would be looking for, does it hit at 3 and negative 1 if you wanted to check it? So I'll go type this in really quickly, or as quickly as I know how. So graphs x to the fourth minus 4x cubed, that part I remember, plus 27x squared. Minus 46x minus 78. There's the moment of truth. We want to make sure it hits the correct places. As you see here, we do have a 0. Analyze graph. 0. A negative 1 like we were supposed to. And then you analyze graph 0 over here. At 3, 0 like we were supposed to. There's no other zeros. That's because the other ones were imaginary. Even if I zoom fit this, I'm kind of scared to zoom fit. Sometimes it throws it way off. Let me just put this out to like 50. And you can see negative 50. This is just making a parabola. We got the right values here. It looks good. So I could keep changing this down until I got the right value. There we go. As you can see, this picture, it only has 2 zeros. Those are them. The other two were imaginary. So we did do this correctly.